Okay, we're back. I kind of got cut off there. I got so excited that I didn't realize that my 15 minutes was up. So we're going to go back to where we ended, except I realized I made a mistake. Here at 21, 21 minus 17.7, I had incorrect. It's not the negative 1.7 that I had. It's 3.3. That should make a little bit more sense. And squared, that's 10.89. 16 minus 17.7, that's the negative 1.7. When we square that, we get 2.89. 12 minus 17.7, once again, I get a negative number. And square that, and I get a positive, 32.49. 15 minus 7.7 is negative 2.7, squared, 7.29. And then finally, I get 0.3, which when I squared is 0.09. Now remember, for our sample variance, we need to have the sum of this third column. So this is when I would get out my calculator, and I just add up all of these numbers. And I already did the work for us. It's 84.01. That is the numerator of my sample variance equation. So 84.01 goes in my numerator. My denominator, n minus 1. Well, n is 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 data points minus 1. That gives me 8 for my denominator. I get about 10.5. The standard deviation is easy to find from there. I simply take the square root of my sample variance. The square root of 10.5 is approximately 3.2. So once again, what does the standard deviation do? It tells us how the data varies. We're actually going to use the standard deviation later in the year to calculate the probability that the data would be at 10 or at 20. We're actually going to be able to use it to calculate probabilities. But for now, we're just actually going to learn how to calculate it. Okay, here's our third example. In the process of tuna fishing, porpoises are sometimes accidentally caught and killed. So there were 8 commercial tuna fishing fleets gave some information about the number of porpoises killed during a 3-month period. So the first fishing fleet accidentally killed 2 porpoises, the next one 6 porpoises, the next one 18, etc. So I want you to find the following 3 things. Find the range, find the sample mean, and then use that sample mean to calculate the standard deviation. So we're going to pause the video right now. So if we could pause the video, and we're going to give you a few minutes to try this problem, and then once everyone has a chance to work on this, we'll restart the video and go through the answers. Okay, so hopefully you've had a chance to work on this and you got the answers. Let's see how you did. The range, remember, is just the biggest minus the smallest. So I got 18. The sample mean is about 7.9. For the standard deviation, we're going to fill in the chart. Once again, is the chart necessary? You could do it without the chart, but it just keeps everything organized. It makes the formula seem a little bit more manageable. So I filled in my chart. Using that mean that I found. So check your chart, see how you did. The sum of that third column is approximately 282.88. That is the numerator. Oh, I forgot a squared here. That is the numerator of my sample variance equation. The denominator, since I had 8 data points, is 7. So the sample variance was 40.4. I took the square root of that and got approximately 6.4. So my standard deviation is approximately 6.4. So hopefully you're getting the hang of this process. There's one last thing I want to talk about today, and that's what's called the coefficient of variation. And what it does is it takes the standard deviation and looks at it as a percentage of the mean. So it takes the standard deviation and changes it to what percent of the mean is that. So here's our formula. CV stands for coefficient of variation. And all we do is we take S is the standard deviation, divide by that X bar, the mean, and then to convert that to a percentage, we multiply by 100. So let's go ahead and try one problem finding the coefficient of variation. This is a pretty easy problem to work if you know this information, if you know the standard deviation and you know the mean. For the past 10 years, the daily high temperature on January 1st in a mountain time in degrees Fahrenheit was given by this. So January 1st, one year was 3, the next year was 25, the following year was -8, etc. Find the range. Well, range is biggest minus smallest. 25 minus the smallest. Well, the smallest is a negative this time. And we remember that when we subtract negatives, we add the opposite. And so the range of temperatures is the 37-degree range. Sample mean. Well, I'm going to add all those temperatures up. I have to be careful because the negatives do have to count as negatives, so those get subtracted. So I do 3 plus 25 plus -8 plus 17 plus -2, etc. I added all those up and I got 64. I have a total of 10 years worth of temperatures. So my sample mean is 6.4 degrees. That's the average temperature on January 1st during those 10 years. And then finally, I want the coefficient of variation. So we have the formula. The coefficient of variation is the standard deviation divided by the mean times 100. Well, let's see. The standard deviation they gave me this time, 12.1, divided by the mean, which we just calculated. And then to make that into a percentage, I'm going to multiply by 100. Plug that in your calculator. I got 189.1%. So the coefficient of variation, 189.1%. Okay, we're going to stop there. And now you're going to get your assignment that is going to be dealing with these problems of range, mean, standard deviation, and then this new idea of coefficient of variation, which I'll talk with you more about one-on-one when I see you in the next class.